So hello everyone. So once again I'm back. So here I'm trying to explain you about work done by the torque. So it's nothing but I would like to derive a formula for the torque just by stating an expression with the help like work done by torque Bolke. Clear? So in this, I would like to consider a rigid body for your imagination in which a particle of a rigid body I am viewing from the top. So let me consider top view of it. So how does a top view of a particle which is under rotation will seems to be like a circular path. See here like this. So a particle moving in a circular path, the whole rigid body, this is the top view you are seeing. So from the top when I see the particle will be in this circular path. So such a particle initially is at its position P1, let me suppose, so where its angular displacement is given by theta, and later after some time t, so let me suppose for a smaller angular displacement d theta, it came forward to P1 dash, and this is happened due to which the force was acting on it at an angle alpha with the line of action of this one, and at the same time with an angle beta to the direction of the displacement. So this is your displacement of the particle, I can say. So the angle made by the force with respect to displacement be considered as beta. So from the figure it is clearly visible to me that alpha plus beta is equals to 90 degrees. So now here work done by torque. So we are going to derive the expression for work done. So what is work done? We already know in previous classes we might have learned, right? So work done, the basic formula for work done W is equals to F S cos theta. So what is F? Force applied on the object. S, displacement of the object carried due to the force applied. And what is theta? Angle between the force applied on the object and the displacement carried by the object or the particle, I can say. So here in this case, what is the force? F. What is displacement? ds. And what is the angle? Beta. So I would like to write this one directly. So therefore I would like, so work done W is equals to F into ds into cos beta. F into ds into cos beta. So where ds seems to be like the length of the arc only for smaller angle made. So I would like to write here again down. So ds, I am considering it as length of the arc. What is ds? Length of a arc making an angle at the center of how much? D theta. So therefore the position vector already we know. So that is your position vector r bar. So for a one single particle, all terms are given R1, R1, P1, F1 and all etc. I just don't want to represent again back over here. So therefore length of arc, so that is equal to length of arc is R1 into D theta. So these all are for first one particle only. So therefore work done is given by, the work done, smaller work done is given by dw1 is equals to F into R1 into d theta into cos beta. I would like to write it as 90 minus alpha, since alpha plus beta is 90 degrees. So the whole thing now rearranges to what? Directly. So dw1 is equals F into R1. So this one I can like F1 only force as for your reference. R1 into d theta into sine alpha. So this is already we know, right? So d work done for a smaller change in work done or smaller work done by force equal to Rf sine alpha is nothing but a torque only. So therefore tau 1 d theta, since tau is given by Rf sine theta. So here Rf sine alpha, see Rf sine alpha. So it is nothing but tau. And for a one single particle it is tau 1. Is that clear? I hope everyone understood, right? So therefore for n number of particles, there are such n number of particles are there. So for n number of particles, for n number of particles, the work done on it by the force F is given by total work done dw is equals to dw1 plus dw2 plus so on, right? And as it is a rigid body, every particle will undergo equal angular displacement. So therefore I can write this one as tau 1 plus tau 2 plus tau 3 plus so on of d theta. Since same angular displacement was there for each and every particle, as it is a rigid body, therefore d theta I took it as outside, and tau 1 d theta, tau 2 d theta. So from which d theta is taken out, which will result you as tau 1 plus tau 2 plus so on till d theta. So this is the expression for now dw. Now let me write this total torque of all the particles as net torque tau, that is rigid body ka torque. So this is one expression I am having. Now let me differentiate this one as small work done we are taking. So differentiate with respect to time t. As we know, rate of change of work done is nothing but power. So power is equals to dw by dt, that is equals to tau into, as it is constant, d by d theta of theta, where theta is angular displacement. So directly I can write this one as d theta by dt. So since angular velocity omega is given by d theta by dt, I can rewrite this one as power is equals to tau into omega. Power is equals to tau into omega, and say this is equation number 1, and this is called as instantaneous power. What power that is? Instantaneous power. So we already know work energy theorem, right? So what is work energy theorem? Work done by all external forces on a rigid body is equal to the change in its kinetic energy. So here I would like to write the kinetic energy expression for the rigid body of containing n number of particles. So in our previous videos we have already learned this one, right? So let me write kinetic energy expression for the rigid body under rotatory motion, that is given by half I omega square. So as work done I derived, now power is also nothing but called as rate of change of kinetic energy only. So therefore d ke by dt is given by d by dt of half into I omega square. As half and I are constant, I would like to only differentiate omega square, so into half I. So therefore it is under chain rule equation. So therefore it will be 2 omega into d omega by dt, that is in chain rule, and that is half I. So overall expression is again nothing but dke by dt is nothing but power only, as we discussed. So that will be 2 get cancel, and omega into I into d omega by dt. Rate of change of angular velocity is angular acceleration. So since alpha is equals to d omega by dt. So therefore this is the expression for power, and say this is equation number 2. So thus I would like to equate both of them. So from 1 and 2. So from 1 and 2. So what is the first equation we got? That one previously, tau omega, and right hand side it will be omega into I into alpha. So thus omega on either side is cancelled because it is constant for the entire rigid body or system of n number of particles under rotatory motion, and thus I got an expression for tau is equals to I alpha. Since we know tau is called as rotational force, so therefore F is equals to I is analogous to mass moment of inertia, and alpha is angular acceleration analogous to linear acceleration, that is F is equals to ma. Got it? So therefore this also can be, this equation can also be called as Newton's second law. This also can be called as Newton's second law for rotation. Newton's second law for rotation, and that too this is for a fixed axis of rotation. So hope you all understood. Any doubts, please do comment on the video. Thank you all. Have a great day, guys.